We're going to look at groups now. Groups are really important in Houdini, and a lot of things that you'll be doing will need to be grouped. For instance, you'll want to affect certain pieces of a geometry. You'll want to partition things out. For instance, grab just this group of geometry and do something special with it. You'll see that groups are used all over Houdini, and it's an important concept. So it's worthwhile taking the time to go through this and make sure you understand how to use groups, how to combine them, and how to manipulate them. So our scene here is really simple. It's just a grid. I have our primitive numbers displayed so that we can easily see them. And we'll just start by putting down a group. So we go into the group folder here and grab group. And we're going to wire right in and turn that active. So by default, it has this name group 1. And if I middle click over here, what you'll see is that by default, every single primitive is added into this group. So we have group 1 with 81 primitives inside it. And you can see we have 81 primitives here, so they match up. If I change this to points, it now becomes a point group. And now you can see that all of our points are in that group. Nothing is highlighted here because I have this arrow active, but if I go to my manipulator icon there, what you'll see is that the group membership becomes more easily understandable here. So if I go back into primitives, now you'll see that everything is turning orange. So we have a visual indicator of what's in the group. So here we can set the group type of what we're trying to set. For instance, primitive points, edges, or vertices. And this is what happens if it has found a group that already exists with the same name. So if there already was a group coming in called group number 1, this would write over anything that's coming in. However, you can choose to add it to the existing stuff that's coming in, create just the intersection, or subtract it. Very useful. You can change the name, so we'll just call this my group. And when I middle click over here, you'll see that has updated as well. So we have a bunch of different things in here that we can use to help how we're grouping this. Not all of these are going to be easily understandable on a grid, so we'll take a look at some other objects as well. But first, let's take a look at the grid. So the base group is a real simple numbering method here. And we can manually say, I want 0, 2, 10, and 15 in that group. And now you can see that our primitives here, 0, 2, 10, and 15 are in there. We also have a icon over here that we can click, and that lets us do selections in here. When we're done with that selection, we can just press enter, and now that updates that group field in here. This field will also take in certain kinds of group expressions. It doesn't work with everything, but it works with a couple kinds, and I'm going to show you where you can find this out here. If you go into here, the side effects doc, and you look up the groups in here, there is a group syntax, and we'll go on to that part here. And this is really useful. There's some interesting things here. So star meaning to use everything. You have a couple component ones, which I'll show here. You've got the N through M ones. So I'll show N through M, which would be like 1 through 25, right? So we're doing 1 through 25. Then we can skip that. And now we can do 50 through 55. And now we're getting that. So we don't have to type out 1, 2, 3, 4, 5, 6, 7, etc. You have this interesting thing here where you can use step patterns in here. I'll show you how that works. So let's say we wanted to select primitives 1 to 50, then we can do a colon, and we can say, actually give me only every other one here. And that gives us this split pattern, or we can skip every third, right? Or select every third, for instance. Very, very useful stuff. However, you'll see that it doesn't work with everything that's in here, such as some of these attribute calls. And that's because these are a little more special and are more appropriate to use in expression, group expression SOPs, which we'll get into in a little bit. The not pattern is really interesting as well, and so is this. So I'll show you how this works. So let's say not 0 through 50. What you'll see is that means anything that is not 0 through 50 is going to be part of that group. Pretty easy. And then there is this other one, which is kind of interesting, which would be, let's say, we'll select 10 through 60. And then we do this little caret. That is the icon that's above 6. If you press Shift 6 on a Western keyboard, you'll find this thing here. So let's say we'll do 0 through 60. However, we don't want to do 23 through 28. So we'll skip those ones. So that selects 10 through 60. However, we have skipped 23 to 28. So some very interesting things that you can do here just with that group pattern matching in here. So I'm going to disable that, and we'll take a look at bounding regions. This, again, is very, very useful. We can use a bounding box that actually has parameters in here that we can move around. It can be a box or it can be a sphere. And you can use objects or volumes, convex holes. But you'll notice that once you start getting into these ones, the object, volume, or convex hole, it only works with points or vertices. I'm going to switch to object so we can see how that works. Now it's going to error out because it wants something coming into this second port here. So we'll use a torus. And we'll make that much bigger. Bring that into here, and it's still erroring because it's a primitive group, so I'm going to change that to points. And now you can see that that torus is controlling what's in that group. Okay, we'll disconnect the torus, and we'll change this back to bounding box. We can disable that for now. Keep binormals is great, more easy to show on a torus, so I'm just going to pipe our torus into here. And when we do keep binormals, we can choose a direction. So let's change this into primitive so that we can see it a little more clearly. And what we'll do is group just the ones that are pointing up. So this is a direction vector. 1 means go all the way up. -1 would mean go all the way down. So this would be X, Y, and Z. So all the ones that are pointing up, and right now the spread angle here is 180 degrees. So that's everything. Now, once I start dialing this down, we get to be a little more strict about it. And as we go lower and lower, well, eventually nothing is matching that threshold there. So something like this is useful for instance, if you were wanting to scatter snow or rocks or something like that on terrain, you're going to want to group by a normal angle. You're going to want to group things that are pointing one way and then scatter things along that group. Include by edges is very useful for harder surface objects. Let's do a quick example here. I'm going to do a box, and we'll make it kind of large and give it some divisions in here. And then we'll grab some random primitives in here and just extrude those. So I'm doing a poly extrude, and we'll just pull it out like that. All right, so I'm going to just wire this over here. And we will disable keep binormals, and we will do include by edges. I'm going to turn that on, and I'm going to change our group type here into edges. So right now nothing is enabled in here, but you can do things like maximum edge angle to group stuff like that. That's not really terribly useful for us, but minimum edge angle is very useful because you'll notice once we start dialing this in here, we find our threshold, usually 20 is a good default, that it's going to group just those hard edges there, which of course can then be beveled. So we could do something like a poly bevel. After that, we can go in here and say we want a group type that we're going to perform this operation on to be edges. And then we can say anything that's in my group. And then we can poly bevel just that edge. And I'm going to make it a nice round fillet in there. Now you'll see we have a procedural way of going and creating these little soft fillets here. No matter what the incoming geometry is, because we have a process here that finds those hard edges and hard angles for us. So I can go back inside here and I can click here and modify this selection even more. Let's say add that to it and then go all the way back down. And as you see, everything has been updated for us. So that's very powerful. And then we have another option here, which I'm going to put this back to our grid, and we'll disconnect that. Make sure we are back on primitives. Turn that off, and we have a randomizer in here, which is incredibly useful as well. So we have a percent, so that's what percent will we like to be randomized into this group. And then we have seeds that we can change to mix and match that around. Very, very useful. We can also use an attribute to control the seed lookup. So currently, if nothing's in here, it's going to use the primitive number to control that seed. But if we had an attribute coming in on the geometry that we wanted to use instead, we could. So by default, it would be set to use the ID attribute, which we currently don't have on our geometry. Group expressions are another very, very important thing to use. In fact, I tend to use group expressions more than I use this node. I'm going to just type group and group expression and wire this in. So I'm going to keep this on primitives. Now, what a group expression does, I'll just call this name group expression here, EXP, is it allows us to type in a little bit of VEX code, usually a very small little string here that can sometimes be a bit more powerful, but it's a bit of a different syntax to use. So let's say that we wanted to group everything that's on the X coordinate that was greater than 0. We can actually call attributes now. So I can say at position dot x is greater than 0. And now that comes in. So by the way, it's using the center point for the prim, which would explain why that center is coming in here, because the center is sort of right on that line for the primitive. All right, so you can keep changing that, etc. If you wanted to do something like prim numbers, so you can call like at prim num is greater than 25. What you'll see is that works as you would expect. Oh, 35, excuse me, not 25. So now that's coming in, so greater than 35. And then we can also do more complicated expressions, and at prim num is less than 75. Right, so I can combine this way. We can even do things like if the primitive number is greater than 35 and the X position, so we're looking this way here, is greater than 1. Right, so we've combined different expressions very easily in a very simple and easy to read way here with this group expression. Now, if you want to combine groups, it can be really useful to use this node, the group combine. And what we'll do is we'll take a look at our groups that are coming in. So we've got this random group here, and we've got this corner group here, and we'll combine them. Really simply, we don't have two different merges. We actually have to merge these into the same. So we have two different group names. Notice they're two different group names. I can do this. I can do a group combine, and I can say we would like to make a new group. So our new group is going to be combined group. And first we start with what's the first thing that the combined group is going to have. It's going to be we'll start with the group expression. So we basically copied group expression into combined group. And now we have choices of how we would like to integrate another group. So I would like to intersect. I'd like to and that. So now we can select the my group in here. And that actually should be a union, excuse me. So there we go. Now they are both part of the same group, and it's a new group called combined group. And again, this can be useful for breaking up your workflow. So you have a group that does one thing and a group that does another thing, and then your third group, which uses some combination of both, can also do subtractions, right? So very useful for subtracting random amounts from a group. So let's say I've got this group here, and this probably should be much, much larger. We'll say that we'll just get rid of this here. So let's say we've got this, but we just want to subtract some random pieces from that. Well, we have this other group here, which is randomly doing stuff. So we'll increase the percentage. And now this is going to subtract random primitives from that other group. So it can be really useful to set things up this way. To invert groups, you have two different options, really. Well, you have three if you want to use vex, but the simple ones would be to do something like a group combine. This is how I used to do things, but they've added a new node, which I'm going to show off very soon. So we'll call the new group invert, and let's say we want it to invert our group expression. Actually, we'll change that one to the my group one. You could just change this to equals all but, and then you'll get the inverse of that group. Now, the new way of doing this is to use a group invert, which is a nice little node, a little easier to understand. So usually I will explicitly set what type of group that is. So we go find the group name that we want, which was my group. And the new name for that is going to be called invert. So we go back up to my group. We can see 8, 26, and 25, for instance. And we go here and we can see now the group has been inverted. So really handy tool. I'm glad it's finally been added in here. Another thing that we can do is if we have identical geometry, we can copy groups. So let's say we set up all of our groups like so. I'll just merge everything down here. And we had a piece of geometry that had nothing on it. We can just use a group copy. It's really simple. We just wire one thing in and wire the other thing in here. And now we can choose which ones we would like. So let's say we wanted to copy our invert group into here, and that should copy it in automatically. So it might not be visible right now, but we can visualize this with something like a color. So I can say color, make sure that it's a primitive, color it red, and then choose our invert group. So now you can see, if you follow this flow here, what's going on is we have a grid, and then we're copying the groups from this whole other path here, and then we are finally coloring anything that's part of that group red. If I bypass that, I just go like that, you'll see it doesn't work because that group doesn't exist. So group copies can be useful when you're copying from one piece of geo that hasn't been set up with groups, and you have an identical piece of geo as well. Now, you can actually match by attribute as well in here. So if you did have an attribute that matched and your geometry wasn't the same, it would try to match those up. A case in point might be, let's say that, well, I'll show you exactly a way to do this. So we have our grid here, and we are going to delete parts of our grid. All right, so we will delete just random stuff. And I should have done it like this. Let's try again. All right, we've deleted random things. And now we'll go to a group copy. And what we should see here when we go and kind of compare the two is that the points are jumping around, the colors are jumping around, and it's because the way that it's matching the groups up is by matching point numbers and primitive numbers up. They don't match anymore because you'll notice once we delete things out, I'll disable this here. Our primitive numbers, you can see them here. They're shifting around. So we need something that's going to stick with the geometry. It needs to stick on this branch here, and it needs to stick on this branch here. So I'm going to use a node here called enumerate. And I'm going to plug this in. And what this does, it's very simple. It just creates an attribute. Here, it's an integer type for every primitive that's on here. So if I spreadsheet that, what you'll see is it gives us an attribute called index, and all that does is copy the primitive number into that attribute. The idea here being that even once you delete things, the index attribute doesn't get deleted, right? So index here is still 80, even though the new primitive number is 61. It basically is a way of remembering and retaining what primitive number that used to be. So what we'll do is we'll change this, instead of index, we'll call that ID. And when we go into our group copy node here, we will match by attribute, and we'll just call that ID. And you see that popped back up. Now when I go over here, you'll see that everything matches and we don't get any kind of popping in there. It can be really useful early in modeling processes, depending on what you're doing, to add ID attributes or index attributes onto geometry. You'll understand a bit more why you need this or where you need it once you get further into Houdini. It becomes especially useful in things like particle simulations where things are becoming born and dying and the point numbers are shifting around a lot, but you still need to have a consistent way to identify points without attributes jumping around. So you'll see that particle simulations usually get tagged with IDs for every particle, which remain constant for the particle and unique to that particle. But in situations like this, it can become very helpful as well. Finally, we're going to look at a group SOP here called Group Expand. It's a very simple one. We'll just look at our torus here. Let me reset our center point for that. And we'll just group one thing or a couple things. So we'll put a group here, go up here and just randomly select a few different primitives here. And this can be very useful for all kinds of modeling operations. So we have a group that's already been set, and we would like to make that group bigger, basically expand it along the geometry. So this is the name of the new group that we'll be making. It's asking what is the base group that you want to start from. So we want to start from that group we set, group number 2. And then you can see here that what it does is it expands it outwards. So if this is the primitive where it used to belong to, it's going to walk along that primitive and find anything that was connected to it. Right? It can be very, very useful for modeling operations and setting attributes and all kinds of other stuff here. And you can play around with some of the settings in here and see what interests you and what you think you're going to find useful in your particular workflows.